Can you guys see? All right. So this is kind of what Langjökull looks like. We came here driving up in the truck, Ice 3, with our lovely driver Rosie, and Sofia was talking to you guys on the way up, right? Now we came up to an elevation of 1260 meters. The very highest point of the glacier is 1450. So we're quite close to the top, right? And like I told you, coming up here, we passed an invisible line at about 1100 meter altitude called the equilibrium line, remember? Now above that line is where the snow doesn't melt away in the summer, right? So that's where all the snow is constantly adding on and not melting away. And there's a hair here. It's constantly adding on, and that creates this cycle of snow starting at the top, making its way slowly to the bottom under the weight of more snow adding on, and then it ends up in the edges. So that's the cycle. Starts up here, ends here. The youngest snow is up top where our car is parked. The oldest is in the edges, right? Now this glacier has been here for 3,000 years. But actually this cycle of regeneration, you know, this cycle of the snow starting up here and ending down in the edges where it melts away, that only takes 300 years. So this glacier is constantly going through this cycle of regeneration where new snow is being added on, and at the same time 300-year-old snow is melting in the edges. Right? Now this is typical for a temperate glacier. All the glaciers in Iceland are temperate glaciers, okay? They're forming in a part of our planet where it's cold enough for glaciers to form, but they melt away rapidly and go through this regeneration cycle, right? Now, that's different from, for example, the glacier in Greenland, the glacier in the North Pole, and the South Pole. Those are what we call polar cap glaciers, okay? Polar cap glaciers. This is a temperate glacier, the other ones are polar cap. And if you would, for instance, drill to the bottom of the Greenland glacier, now I don't know how many of you know this, but Greenland is actually shaped like a bowl full of ice. It's just one big glacier that's just crushed this whole country into a bowl. And if you were to drill down to the bottom of the Greenland glacier, which scientists have done, you would find 100,000-year-old ice, right? 100,000 years old. There's so much pressure down there that actually if you would take 100,000-year-old ice from the bottom of that glacier and take it to the top, when it melts, you hear these popping sounds. And that's the pressure in the air bubbles that have been stuck in that ice for 100,000 years. Now, as you can tell, the oldest ice here is only 300 years old. So the polar cap glacier, the ice can get 100,000 years old. That's crazy. And that's because it's just been adding on and adding on and adding on for so long, and none of it has really been melting away until now, right guys? You all know that our polar cap glaciers are starting to melt? Mm-hmm. Good. There are some people out there that would lead you to believe that this is not a big problem, right? Now, in here, like I told you, it's always 0 degrees, 32 Fahrenheit, 0 Celsius. No matter how deep down you go in this glacier, it's always that same temperature. That's because this glacier is so easily letting water through it. And this water going through the glacier helps the glacier to maintain this same temperature, always just around freezing, right? But if you go deep down into a polar cap glacier, the water doesn't get all the way down there, it's just ice. And the deeper you go, it gets colder. And at the bottom of the Greenland glacier, I believe it's minus 30 or 40 degrees Celsius, so freezing cold. But as you can go all the way down to the bottom of this one and it'll stay at 0 degrees Celsius because of this water, you know, going through it. Now, I like to say that this glacier is like a big sleeping bear. It's a very cute analogy.